Previously we talked about torque. We defined torque as the force times the perpendicular distance about which an object is rotating. Here we have an object connected to a little fixed pivotal point, so the object can rotate around there, but it's fixed there. That's essentially the centre. Now if we apply a force perpendicular to that object, or the perpendicular distance, or the parallel distance I guess there, is right for the equation. So force times distance will give us the torque, the turning effect. If we apply a force at an angle, well, we have to look at something a bit differently. We need either the perpendicular force to a particular distance, or we need a perpendicular distance to a given force. So if we apply a force, we need to know a little bit more about that. Okay, one way of defining solving the equation is to look at the perpendicular distance. So if I come from that, I've just got to extend that line a bit. If I come down perpendicularly to that, I can use that distance. That's the perpendicular distance to that given force. Or, if you like, I can find the component of that force which is perpendicular to that given distance. Either way, it doesn't really matter. Okay, now let's just give a bit of an example here using some numbers just to solve it. Okay, so let's say we've got a given force of 100 newtons. Let's say it's applied at an angle of 30 degrees. And let's say we're given that distance of 20 centimetres. As I said, various ways we can do to solve this. Perhaps the most straightforward logical way of doing it is to find the perpendicular component of the force. That's what we'll do here. Okay, so we have 30 degrees. The perpendicular component of that is going to be opposite of this little right angle triangle. Okay, so obviously that component is the sine component. Okay, so we have f, I don't know, y I suppose, is equal to f sine of the angle. Okay, so therefore just applying our torque equation, torque equals force times perpendicular distance, or perpendicular force times the distance. So it's going to equal F sine theta times d, which is equal to 100 sine of 30 times 0.2. We must be in metres there for SI units to get torque in Newton metres. Now I've run out of space just there, so let's just make that a little bit smaller, move it away a little bit more. Sorry, that's changed all the drawings, but it's okay. So working, which means, so 100 times sine 30, well sine 30 is a half, so that's 50 times 0.2, we're back down to 10 Newton metres. Okay, so that's one way of solving it. As I said before, if we wanted to, we could work out the perpendicular distance to that given force. We would have got the same result.